Kia ora. Today we're going to look at converting nitrate and phosphate data units so that when we compare our data with the lower data and the data that's in the booklet, we're comparing the same units and it's easier to write about. So our data is measured in milligrams per litre. The lower data on the lower website is measured in milligrams per metre cubed. The booklet data is also measured in milligrams per metre cubed. So we're going to convert our data because that means we're going to have to convert one set and not two. So the first thing we have to ask ourselves is how many litres are in one cubic metre, 1 metre cubed of lake water. So if you go to good old Google search and you convert meters cubed to litres, you can find that 1 metre cubed has 1,000 litres in it. So that's our first answer to our first question. 1,000 litres per metre cubed. Okay, so that means that if we want to convert our milligrams per litre to milligrams per metre cubed, we have to decide, do we multiply our value by 1,000 or do we divide it by 1,000? So if I can just take you aside for a minute and get you to think about a cubic metre of water. So if you've got a metre ruler and you went down to the lake and you cut out a cube that was a metre by a metre by a metre, there are 1,000 blocks of 1 litres inside that cubic metre. Does that make sense? There's 1,000 of them. So if each of these is 1 litre, there are 1,000 of them, which means that we need to multiply our data by 1,000 to convert it into milligrams per cubic metre. So if you have an example, a value of 1.5 milligrams per litre times 1,000 equals 1,500 milligrams per cubic metre or per metre cubed. It's the same thing. Okay, so we're going to be multiplying all our data by 1,000 to get it into milligrams per metre cubed. Now, sometimes when you're looking at units, you get units written like this: milligrams and then a long bar slash and then meters with the power of 3 above it. This is the same as writing it milligrams m to the negative 3. And the reason that these are the same is because we need to treat this big long bar line here like a divided by sign. So milligrams per metre cubed is the same as milligrams divided by metres cubed. And if I wanted to rearrange that equation so that I had the milligram part and the metre cube part on the same line, I would then be timesing it by metre cubed. Yes. And I have to do that to both sides. So this would be the opposite of timesing it by a metre cubed, which is timesing it by a metre to the negative 3. Does that make sense? Then these cancel out. And then we end up with milligrams per metre cubed. Does that make sense? I hope it does. It's all to do with writing it all on one line rather than having this long per line. Okay, anyway, these are both the same thing, and that's mathematically how you get to that point. Once you've got all of this class data converted to milligrams per metre cubed, then you can look at the data and compare it directly because they're in the same units, so you know that really easily this one's bigger than that one's smaller than that one. Okay. I also recommend that you look at the two values in the data sets when you're comparing the three data sets. Look at the maximum value for each of the three and the minimum values for each of the three and compare them, noticing that the lower data is modern and up, in the last 10 years. And the booklet data is old, from 1973 to 1994. 1973 was 52 years ago. So that data is old. Just because it's old doesn't mean it's wrong, okay? It is valid. It was measured accurately at the time. And the point of this, of comparing all three, our data plus the lower data plus the booklet, is to look at trends over time, okay? All good? Okay. Ka kite anō.